Okay, so I'm going to talk through the problem. If I were doing the problem, I'll be honest with you, this is the step I would be taking over here. The reason for that, I definitely see a factorization that doesn't require much work. Right, let me just go through that. 4m squared times 4m squared, 16m4. Then what do you get? Minus 4m squared x squared, minus 100, which is 100, minus 104m squared x squared. Then we see plus 25x4. Then what I do, I notice they're perfect squares, difference of perfect squares. So it's going to be 2m plus 5x, 2m minus 5x, 2m plus x, 2m minus x. Worked out beautifully. Now, I got to say, no matter what path you take, it's going to lead to this one over here. Now, certainly in this section of the text, what are they doing? They're trying to get this perfect square thing by seeing a pattern to it, all right? So I hope you realize that, by grouping it, I'll put out what I mean by that we're getting something like this over here by grouping. It's the same thing, by the way. We still get 16m4, we still get 25x4, and minus 40 and minus 64 is minus 104. Now, you may question why they do that. This is why they did that. They recognize a perfect square over there. That would give you 16m squared. You would get 25x4, and you get minus 40m squared x squared. Worked out beautifully. Then what do they do? Difference of perfect squares. They do a little bit of a rearrangement, and then they factor that rearrangement. It's the same story over and over again. Are these getting more involved? They are, but I gotta be honest with you, a little bit thinking up front might prevent a lot of work from being performed. There's nothing wrong with doing the work. There's nothing wrong doing it the way Wells wants you to do it. But if you see something else that's leading to the same answer in the end, please take that something else if it's shorter. All right? Thank you.